Hello everyone. Today our topic is bus topology for distributed control system. First we'll see what is topology. It refers to the layout of connected computer on a network. Some basic topologies are used to connect computers are bus, ring, star and mesh topology. Now today our topic is bus topology. Now in this, as we can see in a figure, there are various computers which are connected through this bus in a line, and one can communicate with the second computer or say any computer in this network. Now as we can see in a figure, suppose this computer wants to communicate with this one, so it first will send a message along with an address of destination computer on a bus. Now next step will be, they will first identify destination among listed computer on a network. After identification of a proper destination, data or message from a bus will move to the destination. In this way, one communication is now completed. Now to understand this bus topology in a better way, we require some basic concept. Now in this bus configuration, every computer, or it can be called node, shares the network's total bus capacity. Means at a time one can hire the total bus. In this configuration, adding more computers will reduce the access speed on the network. Each computer communicates to other computer on the network independently. This is referred to as peer-to-peer networking and sender and receiver concept. Computer which is going to put data on a message on a bus is called sender, and computer which is going to receive data from bus is called receiver. Now next is, let's discuss how a bus peer-to-peer network works. All computers on a network have a distinct address just like our house does. A message would be sent from one computer with the address of another computer attached to the message. The message is broadcasted to all computers on the network until the addressed computer accepts the message. Now let's discuss some basic hardware or components which are needed for bus topology. Coaxial cable, BNC cable connector, BNC-T connector, terminator, and of course computers. Now to communication on a bus is possible in this way. We should be familiar with this concept. Sending the signal, network data in the form of electronic signal is sent to all computers on the network. Signal bounce. Because the data is sent to the entire network, it travels from one end of the cable to the other. Therefore, the signal must be stopped after it has had a chance to reach the proper destination address. Otherwise, it will not make our bus free for next communication. BNC barrel connector. A component called barrel connector can connect two pieces of cable together to make a long piece of cable. As shown in figure, there are two cables which are connected through this BNC barrel connector, and in this way we can increase the length of the cable. Next is T connector. Now as we can see in a figure, these are various T connectors which are used to connect a computer on a bus topology. T connectors are used to join the branch cables with the trunk and they are in T shape. Next is terminator. To stop the signal from bouncing, a component called terminator is placed at each end of the cable to absorb free signals. As we can see in this figure, there are various computers which are connected through this bus topology, and this one is the last computer on a bus topology. So last one is terminate, means bus is terminate with the terminator to avoid the bouncing of free signals. Now next is questionnaire session. After completion of this session, one should be able to list hardware or components which are needed for connection of bus topology, and at the same time one can list out components to be required to connect 5 computers in a topology or any number of computer in a bus topology. Thank you.